So in section 4, what we're going to do is we're going to find the circumference of circles, and then we're going to break that up into smaller circumferences, I guess, and those are called arc lengths. Okay, so remember the circumference is just the distance around a circle, and the arc length is just part of that circumference, so a fraction of that circumference. That's the best way to think about it. All right, so those are the terms. Now, the theorems for those, how to actually find them. Circumference of a circle is just 2 pi times r, where r is the radius. Okay, and the arc length is basically, like I said, how to find it, a fraction, okay, 360, or theta over 360, of the circumference, 2 pi r. Okay, so r is the same, and theta is just going to be the central angle. All right, so if we're going to work with an arc length, what you're going to do is see that you need to find the central angle, and you need to find the radius. All right, so if we're just going to find, let's say we've got the diameter here is 8, and I want to find the this arc length right here. Okay, well, all you do is you're going to use this equation. So you need to find the radius, and you need to find theta. So AL equals, we need theta. Well, theta is right here, 90 degrees. Okay, so that the angle that creates our arc length, so 90 over 360 times 2 times pi times the radius. The radius is half of that diameter, 8, which is 4. So all we have to do is figure out how to simplify this. Well, I want pi in the answer, so I want you to type in your calculator 90 over 360 times 2 times 4, and you should get 2. So the answer would be 2 pi. That's all you have to do. All right, another way to look at this is to find the whole circumference, okay, and then take whatever fraction of it we needed. So if we had to find the whole circumference of this, all we do is do c equals 2 times pi times r, which is half of the diameter, 4. So the circumference of this is 8 pi. All right, so once you find 8 pi, figure out what's the fraction of it that we're looking for. We're looking for, obviously, 1/4 of it from what we set up. So you could just divide that by 4, and that's how you get 2 pi. So we're going to find some circumferences and arc lengths. We're going to find the radius of a circle, work backwards here, with a circumference of 52. Okay, so we know our equation, c equals 2 pi r. All right, we're going to be looking for r, if the circumference is 52. So basically what you have to do is just divide 52 by 2 pi. Now if pi is ever in your denominator, I usually don't want that in the answer. So you can just divide it off, and you should get r equals 8.3. Okay, so it's okay to give me a rounded answer if pi would be in the denominator of your answer. Number 2 here, we're going to find the length of the arc AB. Okay, to find the length of our AB, we're just going to use our arc length equation. Theta is 60, that's the angle that creates AB, over 360 times 2 times pi times r is 9. So we can type it out right in our calculator, realize that 60 over 360 is just 1/6. Okay, so multiply that by 2, multiply it by 9, and the answer is 3 pi. All right, number 3 here, we're going to find the measure of PQ. All right, so the measure of PQ is different from the length of PQ. So if you remember back from chapter 10, we talked about how the measure of an arc was how much out of 360. And it was the same exact thing as the angle that was created. So that's what we're looking for. We're really just looking for theta. All right, so for this one, I've got the same equation, 2 pi r. Okay, now with this, I've got 15 pi is the AL, and 18 is the radius. Okay, so I'm going to be looking for whatever theta is, which is perfect because that's going to give us that measure. Okay, so we have AL is 15 pi equals theta over 360, 2 times pi times 18. Well, one thing to always look for when you're dealing with pi in an equation, especially if it pops up more than once, is does it appear once on each side of the equation? Well, if so, then you could just divide it off and cancel those out so you don't mess with them anymore. That's excellent for us. Okay, so all we have to do is isolate the theta. Okay, so to isolate the theta, we need to divide off 2 So we need 15 divided by 2. Also divide off 18 divided by 18 and multiply it by 360. And you're going to get theta equals 150 degrees. Now, number 4 here, if a tire has diameter of 42 inches, how far would it travel making 10 revolutions? So 10 revolutions gives us a certain amount of, that gives us a theta, right? We want to find the length that you're traveling after 10 revolutions. And 10 revolutions is just 360 times 10, right? 360 times 10 is 3,600. So we want to find the arc length of 3,600 over 360 times 2 times pi times the radius is 1/2 42, which is 21. Okay, so this is pretty easy to see that the 3,600 divided by 360 is just 10. So we just need to do 10 times 2 times 21. And you'll get 420. So the arc length is 420 pi. That's it. Lastly, we're going to find the length of AB. Okay, so another simple type problem. All right, we're just going to jump right into the equation. Theta over 360, 2 pi r. All right, they give us r, they give us theta, so we have everything that we need. 100 over 360 times 2 times pi times 3. And you can just do 6 times 100 divided by 360. That's perfect. We're gonna fraction actually. So remember, you get a decimal, you just hit math, which is right underneath alpha, and then enter, and it'll give it to you in fraction form. So the arc length is equal to 5 pi over 3. That's it.